We have Robert Feeney from the EdgeScan company. He's a security consultant. He just finished his master's thesis in cybersecurity. And he will talk us about web scanners and modern problems, the problems with modern web applications. Please welcome Robert.
Thank you very much. Thank you, Martin. Good morning, ladies and gentlemen. It's an honor to be here at AppSecUSA 2017. I hope you have a wonderful conference. I'd like to begin the morning with a phrase in Irish, and that is Fáilte raibh go léir an seo inniu, and that means you're all very welcome here today. For the next 30 to 35 minutes or so, I'll be speaking about web application vulnerability scanning tools. The content for this presentation, as was alluded to in the introduction, was forged through a mix of academic work which I undertook for my thesis and also through my professional career in using the web application scanning tools on a daily basis. The purpose of the investigation I undertook was to perform in a controlled environment experimentation so that I could evaluate two things. A, identify characteristics of web application vulnerability scanning tools that were impacting scan accuracy and specify areas where improvement was needed. And B, identify characteristics of modern web applications that would impact a web app scanner's ability to find and identify vulnerabilities. So the main goal of today's presentation is that I would like everybody to come away with a greater understanding of the potential pitfalls of web application vulnerability scanning tools and how best to contextualize their use for your organization or for your clients' needs. So without further ado, we'll just run through a bit of an agenda for a small introduction of what we're going to be speaking about. So we'll go through a bio about myself, my work experience and my career to date. We'll detail some background or the latest figures to get a sense of what's happening in AppSec, and hopefully that'll give you guys some indication of what made me look into this area. We'll have a brief introduction into web application vulnerability scanning tools, also known as WAVs, how they work and the different types of data that they produce. The experiment, which I undertook for my master's thesis, will speak about the key points from that in order to evaluate the tools and identify the differences between them. So that will make reference to point 1 made in the introduction. We'll then speak about the problematic characteristics of modern web applications. So that'll make reference to point 2 in the introduction. We'll speak about the web application vulnerability scanning tool evaluation criteria. So that's how you or your organization can best choose a tool that suits your needs. And then we'll have the takeaway and conclusions. So just a little bit about myself. I'm a big MMA fan. For those of you who don't know who this man is, he's kind of the pride and joy of Ireland at the moment. There's also a few words left out there that I can't put on the screen. I did my degree in 2010 to 2014 in Dublin Institute of Technology. I had the opportunity while I was doing the degree to work in an IT support role for a government body, which I did. So that led me into then looking into IT security. More recently, I did my master's, and as I said, this idea was born from the thesis. So in total, I've got 5 years IT experience, 3 of which are specifically in cybersecurity, predominantly surrounding web application security. I would say 70% of my time is focused on that through my work with EdgeScan. So I'll just provide you with some context of what made me look at web application vulnerability scanning tools. So this data is taken from the Verizon data breach report, as you can see. And if you look at the top left-hand side of the first figure there, you'll see that web application attacks are the #1 cause of breaches. And they're also, on the right-hand side, the 4th most common cause of incidents. So the key difference between a breach and an incident being a breach is where there is confirmed disclosure of data to an unauthorized party, and an incident being where there is an attack on integrity or availability, so a denial of service or a web defacement incident. Of the known causes of the breaches, SQL injection is the 2nd most common cause. And I guess it's why OWASP have coupled injection issues into one category in the OWASP top 10. That includes SQL injection, XML injection, etc. And that's really why I looked at injection issues when I was undertaking this experiment. So some notable web breaches are, I guess, organizations that have been hacked through their web applications in recent times. Heartland Payment Systems in March 2008 were hacked via a SQL injection in one of their web apps. That cost them $140 million between the investigation fees, the legal fees, and the fines. Also, we have the TalkTalk hack, which a 15 to 16-year-old boy did an easily exploitable SQL injection and stole 157,000 records. And as a result of the ever-growing severeness of the fines you see in the EU, especially with the new GDPR regulations coming in, they were fined 60 million for just 160,000 records that were lost. The next website, a website I'm not all that familiar with, is Adult Friend Finder. They were the victim of 340 million accounts being stolen. Some of those accounts included US government email addresses, military addresses, and that was as a result of a local file inclusion. And then more recently, as I'm sure most of you are aware, Equifax were hacked. 143 million customers, many US citizens had their social security numbers taken, and that was hacked as a result of an older vulnerability in the Apache struts component that they had on the framework on their website. Really what I'm trying to say here is that the effects of bad web application security can be disastrous to an organization and can kill their business overnight. So there are a number of ways organizations secure their applications, and they do that through looking at secure development practices, automated or manual secure code review, penetration testing, vulnerability scanning, and I'm sure I've left out numerous ones. So that led me down the massive rabbit hole that is web application vulnerability scanners. And web application vulnerability scanners come in, I guess, many different forms, but they're usually referred to as dynamic application security testing tools. They're basically the polar opposite to static application security test tools. So the difference between them is static application security test tools test code, source code, while it's not running, and dynamic application security testing tools test the applications in their operating state. So while the application is being used, so from the perspective of a user. They are outside in, so they're black box, and they're highly automated. They can come in a more automated state or in a proxy-based tool. They interact with the raw requests, and what they do is they inject into those requests in order to provoke a response in the application. Then they analyze the application response in order to try and determine to see if a vulnerability has been identified or not. So in general, we have two types of web application vulnerability scanners. The first type is the automated. They're highly computerized tools. They're very much point and click. They have a strong GUI. In most cases, you just provide it with a URL. Sometimes you give it credentials, and you give it a list of tests that you want it to perform, and it's click, point and go, and it does the scan. And traditionally, what it does is it crawls the pages, puts them into a DB, injects the attack vectors, and then analyzes the responses. Then you have the proxy-based tools, and these tools are favored by penetration testers, and they are more manual and they're more customizable, and as you can see from the diagram, they work a little bit differently. Usually you have a web browser that's hooked up to a proxy tool, so it's very much a man-in-the-middle based approach, and then you have the outbound network traffic going to the web server. The user builds the links manually by visiting them in the web browser. However, they are becoming more automated, and they're very much improving on a monthly basis to be more hybrid of fully automated to proxy-based tools. So there was some previous research done into these tools that highlighted specific problems that these tools were facing. One of the biggest pieces of research that was done was by a gentleman named Adam Dupay, and that was called Why Johnny Can't Pen Test. The situation that it presented was 11 tools were pitted against each other in an environment and tested in order to check false positives, false negatives, and true positives. And a false positive is when a scanner identifies or believes it has identified a vulnerability upon further inspection from a human. When the vulnerability is validated, or in this case invalidated, it finds that it was actually not a vulnerability. Then you have a false negative where there is known to be an issue and the scanner misses it. So it's simply when the scanner misses a vulnerability, and then a true positive when the scanner successfully finds a vulnerability. And this study found a number of issues. The first issue that it found was that, and as we would expect, the commercial tools are a lot better at finding vulnerabilities than the open source tools. It also found that there were issues with the crawlers and the web applications. And one of the biggest things about the crawlers is that, the crawlers attempt to find pages that a user hasn't found manually themselves. Now, if you don't find those pages, you're never going to scan for them. You're never going to test them to see if there's vulnerabilities there. So the crawlers are usually held in higher regard than the testing techniques and vectors that are used, because you can find the page and scan for it, or scan the page with different vectors in order to try and find a vulnerability. And if the vectors are bad, you won't find the vulnerability, but you certainly won't find any vulnerabilities if you don't find the page. That highlighted issues in HTML parsing, where malformed HTML made it difficult for crawlers to navigate through web apps. And it also highlighted issues with dynamic URLs, so URLs that were changing while the application was being used. So for example, think of like a live score center or a sports center where there's live games going on, and you go visit the URL. Because the game is live, you'll see the results, but it may not be there in a week's time when you go back to it, because the game isn't live anymore. And then also there was a study done by Nidal Khoury, and I hope I've pronounced that name wrong, or I hope I've pronounced that name correct. Apologies if I haven't. And that investigation was done in order to check for SQL injection issues. And that investigation found, and I quote, "The results show that existing vulnerabilities are not detected even when automated scanners are explicitly configured to exploit the vulnerability." So that shows two things: weaknesses in the test vectors that were originally used because it didn't find the issues in the first place, and secondly, weaknesses in the analysis section of the web app vulnerability scanning tools, so that even when they were pointed in that direction and shown there's a vulnerability here, it still didn't find it even after it was told. Finally then, Jason Bao conducted a similar experiment which highlighted issues in identifying stored vulnerabilities. And stored vulnerabilities, like stored cross-site scripting, are issues that are executed further down the workflow. So if you inject into a parameter that a user has access to, and until you visit a page, 10 pages later it doesn't pop, scanners are having difficulty finding those issues, and that is something that we address further down the line. So due to the fact a lot of the research that has been done on web application vulnerability scanning tools is older, I wanted to rerun the tests with modern tools simply because they change so much. Architecture of web applications changes so much. Simply the features, everything just changes so much in cybersecurity, and especially AppSec, that I thought it would be a good idea to rerun the tests. However, when I did so, I reminded myself of this quote from Theodore Roosevelt, which was, "Complaining about a problem without posing a solution is called whining." So I guess in some of these cases I will suggest improvements, where improvements can be made in some areas, and I do propose solutions to some of the problems, but some of them I don't. So I guess according to Theodore, I'll just be complaining. So here's the experiment, and I guess this experiment was a result of academic requirements. So it was, can the sampled commercial web app scanning tools provide superior vulnerability analysis over the sampled open source tools when detecting cross-site scripting and SQL injection? And I had to be very specific about the vulnerabilities that I was looking for in that case, and that was why I chose the injection-based vulnerabilities. So here's the setup of the experiment. So I guess for legal reasons, I've omitted the two commercial scanning tools. So we've got one automated tool, one proxy-based tool, and then we have two open source tools, Arachne and Zap. 4 web applications with known vulnerabilities. And the reason we need the known vulnerabilities is so we can measure the false negative rate and the true positive rate. And each of these applications have different underlying architectures. So they would be unauthenticated apps, apps with authentication, apps with CSRF tokens, and you'll see the reasoning for that as we go down further. Of course, then the manual validation occurs after the scans are being run, and that data set produces the list of false positives, false negatives, and true positives. And I guess, personally speaking, I believe that a false negative is far worse than a false positive, because false positives just mean that you dedicate 30 minutes to an hour of manpower validating that an issue is real or not real, depending on the vulnerability, whereas a false negative misses a vulnerability that can be totally disastrous. So false positives are not the end of the world, but false negatives are pretty bad. So here's a high-level overview, kind of messy enough diagram of the experiment. You can see stage 1 is the scanning, so it's all 4 of the tools being pitted against all of the applications with the cross-site scripting and SQL injection scanning. Then we get to the unvalidated results stage, and after that the manual validation occurs. The manual validation wasn't done just by myself, it was a number of different people, again, just to emphasize the fact that you're only as good as the person validating the issues. So where some person may not validate an issue as correct, another person might. So I got more people to do that just to make sure. And then the stage 3 is the results analysis. So this is what it produced. And on the left-hand side here, you'll see the SQL injection statistics from the scans that were produced. Now, not too much of a difference between the tools. You'll see the tool that found the most issues found 18 SQL injection issues, and the tool that found the least was 14. And thankfully, all of the tools identified more issues than they missed. Unfortunately, the same cannot be said for the cross-site scripting issues. The tool that found the most found 14, and the tool that found the least only found 5. And it actually missed more cross-site scripting issues than it found. And this is something that gets addressed. So I guess the key findings to this study were the 2 open source tools had the highest number of missed vulnerabilities overall, and the 2 open source tools also missed the DOM-based cross-site scripting issues. Now, that's not too surprising, given the fact that commercial tools are highly profitable, simply because they have the ability and the money and the time and the resources to develop those different areas, and open source tools simply just need more contributors and more people helping them and aiding them and making them better. However, this next point was something that piqued my interest greatly. If you see from the results section on the cross-site scripting, Arachnoi found more cross-site scripting issues than Zap did. So I had a look at the attack vectors that it was using. And Zap had twice the amount of attack vectors, but only found half the cross-site scripting issues that Arachnoi did. And the reason for that is, I believe, the attack vectors that one of the tools uses is of better quality. And what I would like you to do is, just by a show of hands, on the left-hand side you'll see the span script payloads, and underneath that, hands up if you think the payloads on the left-hand side have a better chance of popping a cross-site scripting issue. Okay. 4 or 5 people put their hands up. Hands up if you think the vectors on the right-hand side have a better chance of finding a cross-site scripting issue. Okay, way more hands have gone up there. And you are absolutely correct, because they are the Arachnoi vectors. And you'll see Arachnoi had 3 cross-site scripting tests. OWASP Zap had 6. Now, I believe that the vectors from Arachnoi found more issues, because generally speaking, those vectors will have a better chance of breaking out of different types of HTML tags. For example, on the left-hand side, on the bottom, the script alert from the OWASP Zap section has a single quote, double quote script alert. That will only break out of a certain number of HTML tags. However, if you look on the right-hand side and the Arachnoi vectors on the bottom right, you'll see the same vector, but you'll also see the / text area, and you'll also see the double hyphen greater than symbol, which also breaks out of any commenting areas in a web server response where a input field may be reflected. So to me, the complexity of the vectors count.
That
Okay, so it's trying to bypass the...
It's not that they're not breaking out enough stuff. This app actually does a really good job of figuring out where the page it is, in what context it needs
Yeah.
to break out, but then it doesn't put the right things in there to test what might be possible from there.
Okay.
From my experience too, the IDPs or inline protection systems,
Yeah.
apps, things like that, they're always looking for things, the scripts that include alert or any type of pop-up type of activity.
Yeah.
And that's common too, even from a validation standpoint, is what we learn to try to validate.
Sure.
The pop-up.
Yeah, exactly. And I mean, you know, I've seen vectors from commercial tools where they'll have removed the alerts in some of the vectors simply because WAFs were blocking them. But then, you know, you're opening yourself up to a lot of false positives, and you know, not necessarily a bad thing because you just have to validate them, right? But I think it emphasizes the point that the complexity of the vector counts. So the more different types of complex and advanced vectors there are included in different tools, the better. So I mean, six vectors and 3 vectors isn't an awful lot, and I guess the more quality vectors you have, the better. And I guess obviously the one on the top left in the OWASP app section is a vector that is obviously encoded, so it's there to try and attempt to break out of certain encoding, and that's great because some apps that will work for and some it won't. So all of those, you know, the more advanced vectors there are, the better. So then the next key result that I have was that all tools missed the stored cross-site scripting issues. I just want to explain the difference between the stored XSS issues. So one is that, so basically stored cross-site scripting is executed further down the workflow or not immediately upon the response after the initial attack vector is injected. So you've got same user cross-site scripting. So if I'm logged in and I add an appointment and I inject some cross-site scripting vectors in, and then 10 steps later when I view that appointment, then it pops. And then you have different user XSS. So if I'm logged in as user 1 and I add an appointment and that doesn't pop until user 2 accepts or rejects that appointment, that it pops in their portal. So my potential solution for this is to add a random integer to the vectors that it is inserting into different points, and then store those vectors in a local database of payloads. So for example, if you look up at the screen here, you'll see I have script alert, and then, you know, and obviously the entropy of this can be whatever the person deems necessary, so that no 2 attack vectors are the same. And if they're not the same, that means if you ever see that vector again in any of the web server responses and you cross-reference those responses with a local database of all the vectors that have been inserted in the different parameters, then you can see exactly where the stored cross-site scripting has been injected. And if there's a match anywhere in any of the responses, you can flag that issue as a potential stored cross-site scripting. And again, at the very worst, it may just be a false positive, but that's okay. One of the next results was around one of the previous points made around the crawlers. So 3 out of the 4 scanners found 5 times more pages than actually existed on the tested applications. And this is something that gets addressed further down as well. So if we link this back to the previous research that was done, in regards to the crawlers, there's a lot of work being done by numerous different vendors of different tools. So, you know, some tools have automatic URL rewrite rules where they attempt to find and identify where this functionality may be in place so that it ignores it and doesn't cause your sitemap to be populated with lots of junk. Then there's linked depth crawlers and recursiveness. So you can restrict how deep the crawler goes into the app, and you restrict if it finds the same item like 15 times. So if you go to a shopping cart and there's 1,000 different products, you're really only scanning the same thing 1,000 times. So you can just scan it once or twice, 3 times, whatever. And then you've got folder and path exclusion. So really customization is the key in terms of web application vulnerability scanning tools in regards to crawlers. Testing techniques and vectors still need to be improved, but as I said earlier, the more advanced vectors there are, the better. It would be fantastic if tools had the ability to add your own custom attack vectors to the tools, and I know some of the automated tools do that. And then, as you've seen, the stored vulnerabilities still need a lot of work, but there's still work to be done there. So web apps have changed considerably over the last number of years. And as people and I guess companies and organizations in AppSec have started creating defensive techniques and making things more secure, this has had an effect on a web app scanner's ability to perform scans on the applications. So I guess there's some known pitfalls, and I like to call them the usual suspects, so the ones that we know already impact a scanner's ability to find vulnerabilities. So infrastructure, so again, the network that the target lies on, the machine that it's on. If there's any network interference, then that can have an impact on time-based attacks. You'll get false positives for time-based attacks. Problematic functions, so functions like contact us pages, where you'll scan that and it'll create thousands of database entries in some poor support email address. Change passwords or a logout button. If you scan a logout button, then you're going to invalidate your session and you'll have to relog back in every time. Sessions, one of the biggest things that web application vulnerability scanning tools are having to deal with. Recognizing a session as being in session or being out of session, and then having the skill to relog back in and verify that the session is in fact valid. And then you have account lockouts. And this is something that I've seen personally happen to a friend of mine who works for a large technology organization in Dublin. And the team that he works for gets the web app scans done by a different team in a different location. But whenever he got the scans back with the vulnerabilities for the application that he was looking after, whenever he went to validate those issues with the credentials that they used for testing, he always found that the accounts were locked out. Now, because the accounts were locked out halfway through testing, that means that anything done after the point of lockout was invalid. So, it took them, I'd say, 3 or 4 iterations of this to realize that there was some problematic functions causing the lockouts. And they actually found some cross-site scripting and SQL injection issues after they remedied that, because they hadn't been scanning the application in its entirety because of the account lockouts. And then we have application volatility. And this is just really how temperamental an application is and how often it will invalidate your session because it doesn't like what you're doing. So because apps have changed so much over the last number of years, there are some new defensive techniques that have been implemented. I like to call them the new kids on the block. And they are, of course, the first thing that springs to mind is CAPTCHAs and anti-automation. So things like I am not a robot, the CAPTCHAs that we see on a number of different applications that we use regularly. And these are a nightmare for automated web application scanning tools. And the reason for that is because they're never the same, and they always change. And especially if you're using an authenticated app, when your session gets invalidated, always happens in scanning, you have to relog in. But when you relog in, you have to fill in the CAPTCHA again. And this proves quite difficult for automated tools. Now, ideally, in QA and test environments, you would like to consider that they be turned off. But also, in situations where that's not possible for like a production environment, the manual proxy tools are more suited towards that, because you've got to manually fill in the CAPTCHA before you get your session back. And then we have the multi-step logins. So pages where a successful previous step is needed in order to proceed and get a successful response for this request in question. And the example I have of that is your banking application asks you for your PAC numbers. And these PAC numbers will change every time you log in, right? It's a security feature. So because it's asked randomly, now you can obviously write some script or some macro to have some logic to respond to the numbers that it's asking you for. However, again, this is something that the automated tools are struggling a little bit with, because certain tools you can write plugins for to do this, but other ones you can't. So again, it's more suited towards the proxy-based tools in order to respond to the digits that the PAC number is asking for. And then we have one of the biggest emerging things that is happening as a result of changing web application architectures, and that's CSRF tokens. And a CSRF token is a token that is embedded into the web application that the user must submit along with a session token in order to, for the request to be deemed valid. So I guess I've categorized them into 3 different types of CSRF tokens. You've got per session. So a per session CSRF token is usually something that looks like this. If you look down the very bottom there, you'll see it right alongside the CSRF token. I like to just consider them as a second session token. And most tools will handle that absolutely fine. And then you have something that throws a spanner in the works, the CSRF token, but it's a per request CSRF token. So this is a value that changes every time you send a request. So when you send a request, you get your valid response from the server for the action you've performed, but it gives you a new CSRF token that you have to send when you're looking to send another request. And the automated tools, again, are having a hard time dealing with this simply because the names of the tokens and the places in the forms where they are, it's something that's more suited towards the proxy and manual-based tools. And then to complicate things even further, you have CSRF tokens or values that are tied into particular forms. So without this token, when you submit that form, the form will not be accepted by the web application because it doesn't have the value. And again, something that's more difficult to do with an automated tool and is suited more towards proxy tools because you can write the business or the logic to do that. Then we have non-standard error messages. So I guess recently some organizations have started writing custom error messages just for user experience, and as a result of that, we've seen where they'll have a 200 OK response, but they'll have like 404 not found in the body of the web application or the HTML. And what happens there is when the scanner is crawling, and of course, when scanners are crawling, they put in random strings in order to try find, like if you're using Dirbuster, you would try find different directories that weren't directly linked to the app. The crawlers think that they have found a legitimate link, and then they add that link to the sitemap or the list of links that you're going to scan, and it just clogs up the scanner. Now, what that does a number of things. First of all, it delays the time that the scan takes because you're scanning a lot of junk. And then secondly, depending on how the application responds to you visiting these crazy links that you think you've found, it may actually cause your session to invalidate, which you then have to relog in. And it just complicates scans simply because of the amount of pages that the crawler has found. So some automated tools have attempted to address this automatically, but the best way to do this is to personalize the scope. We then have non-standard protocols. Simply put, this is just that certain protocols are not handled by certain web application vulnerability scanning tools. So some of them are quite good at handling WebSockets, some aren't, some don't handle REST API. You can do a daisy chain technique where most of the web application vulnerability scanners allow you to create an upstream proxy to another tool. So you can proxy tools together in order to intercept the traffic in a different way. That's one way around it. Finally, we have then the other guys. And one of them is a name level check. And this is something that I've seen recently. So a name level check is a check on an application request where the app does not accept more than one entry in the database where the parameter in question has a duplicated value. So if we look at the request above here, you'll see on the bottom line, there are 3 different parameters: appointment name, first name, and second name. So the application will not accept an appointment name that has already been added to the database. So it just won't allow duplicates because it doesn't want any appointments with the same name. So the way the web scanner works is it takes this request and it starts with parameter 1, and it makes its injections into those parameters. And based on the response, it'll flag different vulnerabilities. It'll do all of them or most of them fine on the first parameter because when it's injecting into that value, it's changing it, so it will accept it on the database. But then when it gets to parameter 2 and 3, because parameter 1 is the same, you get an error message that says, sorry, an appointment with that name already exists. And you will get that for parameters 2 and 3, meaning that the tests for those two parameters aren't working properly. And as such, you may miss stored or reflected issues such as SQL injection and cross-site scripting. So what you need to be able to do here is you need to be able to iterate through the appointment name so that every request that is sent is created with a new appointment name. Otherwise, you'll miss certain vulnerabilities. So for example, if you look at the appointment name in the top line, you'll see board meeting 1, and then you inject your payload, and then you'll see board meeting 2, and you inject your payload again. And again, it's something that's more suited to the proxy-based tools, simply because you can write the logic to iterate through each request to change that value so that you can get a successful response. And when that value changes, it'll pass the name validation, and the tests that are being done for the other parameters will be accepted. Last but not least, we have component security. And I guess component security is something we're seeing a lot more recently, especially with the Apache Struts issues and the likes of WordPress. And some scanners test for these, some don't. It's just that simple. So one of the best ways to evaluate whether particular web app scanning tools are good for you or your organization is to use the Web Application Security Scanning Evaluation Criteria Project. It's a bit of a mouthful. It's an OWASP project, and it bases the characteristics of a tool on 8 different characteristics. So the ability to communicate over the desired protocols. So the tool should be able to intercept and manipulate traffic based on what protocols you're using. Secondly, you have authentication, the ability to log in. Third, you have session management, so recognize when a session is invalid and relog you back in. Crawling, the ability to find other pages and spider the application to build a sitemap. Parsing, of course, find the input fields that you're going to inject. 6, you have testing, so the ability to inject and perform tests. Command and control, that's simply just visibility. And then reporting, displaying the results in a human readable manner backwards afterwards. There's also a white paper recently written by Barbara Filkins, asking the right questions, a buyer's guide to dynamic scanning to secure web applications. And that's a fantastic resource for aiding you in selecting the right web application scanning tool. So what I would like to emphasize here is that personalization and contextualizing is really what needs to be done for each web app that you're scanning. Default policies aren't enough, and specifically, some tools will do certain things to particular parts of the request that other tools won't. So they will skip certain areas. They have different attack insertion points. They may not attack the URL path folder. They may not attack the body. You have to specify those things and be really clinical about what you're doing and where you're doing it. Specifying crawler depth limit and recursiveness. So some websites have duplicated websites in different languages. Again, if you do scan them, you're just making the scan longer. So you can cut that out by removing those folders. URL rewrite rules. Then you have folder path exclusion. So deeming them as in scope or out of scope helps to reduce the time it takes. And then selecting the types of tests that you want to run. Sometimes tools come with thousands and thousands of tests, but you might only just be looking for the OWASP top 10, and certain tools give you the ability to do that. So in conclusion, knowing your web architecture means that you understand how your web application works and what features it has, and this will allow you to make the best decision possible when deciding which tools to use on your web app. But do not rely on one tool alone. Mix them up, because some tools are great at certain areas and weaker in other areas, and they do complement each other. So mixing up your tools is a good way of getting a good, solid level of coverage. Investigate what your tools are doing via proxying them, and you'll see exactly what needs to be improved on. If you invest the time in doing so, you will reap the benefits of using web app scanning tools. In general, I feel the more complex an app, the more suited towards proxy-based scanners it is. Special thanks to Owen Keary, Raheem Gina, and EdgeScan, and OWASP. Thank you very much. Cheers.